Hi everyone, I'm Esma and welcome back to the channel. Hope you guys are doing great. So I'm finally back with the video, and today we will be finally discussing the last part of our first lecture where we will be trying to understand that what is exactly information and computing and what are bits. So before we proceed with today's lecture, let's just have a brief recap of what we did in the last lectures. In the last lecture, we were trying to represent information using coins and dice. And we saw that since a coin has got a total of 2 states, therefore it represents a less amount of information as compared to a single die that has got a total of 6 states. And with the help of the example that we discussed in the second part, we reached to a very important conclusion, and that is that anything that has got 2 states represents the least amount of information. And we stopped right there, and we then further said that it's an interesting way of using the word information, because in our daily conversations, when we're using the word information, we associate it with knowledge. But when you're saying amount of information, then that means that you're using the word information quantitatively, meaning that you're talking, you're saying that information is a quantity that can be measured. And that's an interesting way of using the word. So now we want to understand that why we can use, why this word is used in this way in computing. So to understand this, we need to understand that what is information and in computing. And with this, let's start our today's video. Without wasting your further time, I'll share my screen. Okay, so here's the screen. I'll stop my video and full screen. Okay. So before that, let's just try to, first of all, let's just try to understand the difference between data and information. You have heard of these two words, but what is the difference between data and information? They sound similar, but they're not similar. There is a difference between the two words. And what is that basic difference? So data is something that is unprocessed, it's unorganized, or basically it's something that is in its raw form. And that raw form and that unorganized form basically is of no use to you. It does not have any meaning. So it's not meaningful. But if you process this data, if you process this unprocessed thing, or this raw material, it will become something useful, something meaningful, and that thing is known as information. So information is nothing but a processed data. So you have data, you perform some process, and you convert this data into an organized meaningful form, which is known as information. To understand this difference in a better way, we look at this example. So let's look at a couple of examples. Here are 3 examples right in front of you. And you can see this left basically column is of data, examples of the data. And we want to see that what is information, right? So let's look at the first example. We have got like 3 numbers here, 2, 10, and 15. And there are 3 colors, red, blue, and green. Now, I know that 2, 10, and 15 are 3 colors, and I know that red, blue, green are 2, 10, 15 are 3 numbers, and red, blue, green are 3 colors, but I don't know what to do with this. This is not enough. I mean, these 3 numbers could represent anything. It could represent, let's say, the length of something, the volume of something, the area of something, or maybe time, or maybe temperature, or anything, or maybe the number of objects. Maybe red, blue, green are the colors, of maybe some object, but again, we do not know that what is the connection between these three numbers and these three colors. So if you just give this to me, it's of no use to me. It has no meaning to me because I don't know what this is. But if you provide me some context, so then it's going to become meaningful. So basically, when you provide context to data, it becomes information, which is something useful and something understandable by humans. So the lengths, if you just say it like this, the lengths of the red, blue, and green wires are 2, 10, and 15 meters respectively, then this makes sense. Now you understand what this red, blue, and green represents. These three colors represent the three wires. And these numbers here represent the length of each of the wires here. So now it makes sense. It is meaningful. It's conveying something. It's conveying the message now. Now you understand what's the connection between the colors and the lens. Let's look at the next one. You've got like three names here: Abdullah, Sarah, and Alice. Okay, there are people. These are the three names, but what do I do with these names? And why are they important to me? I don't know. If you give it to me like this, I don't know who these people are and what should I do with them. Why are they important? I don't know. But if you say something like this, that the following students have recently enrolled in the programming class: Abdullah, Sarah, and Alice. Now this makes sense. Now you understand that, okay, Abdullah, Sarah, and Alice are three students who have recently been enrolled in some programming class. So now you have provided me some context, and now I know, I can understand this. Let's look at the third one. You've got this here, 11:30. Now, this thing over here, it may represent time, but I'm not sure if that's the time, because in this way, we also represent the ratios, right? We write ratios in this form as well. So I'm not sure if that's the ratio that we're talking about, ratio of something, or it's time that we're referring to. So if you just give this to me, it again has no meaning. But if you say this, that the bus will arrive promptly at 11:30 a.m., so now I understand, okay, this 11:30 refers to the time at which the bus will arrive. So I hope you, by looking at these examples, you kind of get a sense of what is data and what is information, and what is the basic difference between them, right? Now, since we're talking about computers, so computer is an electronic device where our data is stored, right? Where we store our images, our maybe electronic books, our songs, maybe movies, videos, audios, everything. So all of that is stored on your computer, right? And that is basically data. Now we want to understand that what is the language of a computer, right? Let's just first look at what is the language of a computer. But before discussing that, what is a language? Language is is actually something with which you communicate, right? So there are many languages that exist in our today's world. English, for instance, Urdu, Hindi, English, Chinese, Japanese, Spanish, so many languages that exist in our world today. And these languages are used to communicate. We use languages so that we humans can communicate with one another, and communication is a very important mode of survival. If you don't know a particular language, for instance, if you go to some country and you don't know their language, then it becomes very difficult for you to survive there. If let's say you take me to Japan, I don't know Japanese. I don't even know how to read the language or write the language or speak in that language. So it will definitely become very much difficult for me to survive there. But if I know a language that the Japanese and for instance, I know English, so I can assume that there might be some people there in Japan who understand the language. So I can use English and communicate with them with this language. But again, it will make things a bit easier for me But then there are many people who might not know English and they just know Japanese. So in order to communicate with them, things would get difficult for me. So to survive there, I would need to have the basic knowledge of their language so that it's easier for me to survive there, right? So language is a very important um, thing for us. It's an important thing for us to survive. Because communication is something that almost our entire world today depends upon communication. So now all the languages that exist in this world, uh, Urdu, Hindi, English, French, Japanese, Spanish, whatever, all those languages that exist in the world, you can type them on your computer, right? You can type all of those languages on your computer. And like if you type them on Google, you can find all those languages. But does the computer understand all of those languages that we humans understand? No, the answer is no. The computer does not understand the languages understood by humans. It has its own language that it understands. The data that you store inside your computer is stored, the computer stores it in its language. What is that language? The language of computer is known as the binary language. Binary language is a mathematical language, and it is a language that is based on binary number system. Binary number system is a system that simply consists of 2 digits, and that's zeros and ones. So the language that computer understands is of zeros and ones only. You construct binary numbers with a combination of zeros and ones, and that combination of zeros and ones is the language that your computer understands. Now, all of the data that you store inside your computer, for instance, your images, or maybe your electronic books, or let's say some Word document, or your videos, maybe your audios, or maybe songs, pictures, anything, all of that, that entire thing is stored in that binary language. Binary language is basically a code that your computer uses and understands. Binary language is not understandable by humans. We humans don't understand the language of computer, and the computer simply does not understand our language. So if you want, the only way it will understand is that if you provide relevant code of that particular language that you understand to the computer, that's how it will understand. So all the images, even the video, this video that you're going to watch on YouTube, that's also stored in zeros and ones, right? That is, this is what, so if you, for instance, see this written here, this is English language, right? This is what you see here, but what goes inside, what's going on inside computer is basically zeros and ones. Now, what are those zeros and ones, and why it's just the binary language that is used by the computer? Why does the computer just use this language and not any other language? So to understand that, you need to understand that a computer is basically an electronic device, and it has got like many circuits inside it, wires, transistors, everything with those electrical circuits. It's an electronic device, right? And since it's an electronic device, therefore, the wires that it has, and everything, the wires or the circuits that it has, electricity passes through them, right? There are electrical pulses that are inside the computer. And electrical pulses exist in 2 states. They exist either on or off state. So off state means that you don't want the electrical pulse to pass through. And off state means that you don't want the electrical pulse to pass through, right? And on means that you want the electrical pulse to pass. So this zero here, and the one that we're talking about, these 0 and 1s are basically known as the bits. So a bit is basically just the smallest unit of information. And a bit has two states, that's 0 and 1. And now we were talking about those electrical pulses. Those electrical pulses exist in these two states, the zeros and ones. So the 0 actually represents that no electrical pulse is being passed. The 1 here represents that yes, the electrical pulse is being passed. So the way the things are stored inside your computer is basically the sequence of those on and off pulses. It's simply like turning on a switch and turning off the switch, right? So it's that sequence that the computer understands, the sequence of those electrical pulses, and we represent those electrical pulses, the state of that electrical pulse. Where if there's no electrical pulse, we're going to say that it's the state 0 that we have. If there is an electrical pulse, we're going to say that there's a state 1. So it's that sequence that is the way the things are stored inside your computer. Now, let's look at this. I hope that you guys know, you've heard of ASCII. It's an abbreviation of American Standard Code for Information Interchange, right? And this is basically a table. It's actually taken, I've taken this image from this book here, Introduction to Classical and Quantum Computing by Thomas G. Wong. It's an excellent book. So if you're someone who really wants to understand classical and quantum computing from the very basics, you can download this book from the internet. So it's a very nice book. You can go through it. So I've taken this image from this book. This image right here tells you, now look over here, that this A, B, C, D, E, F, G, these are the English alphabet that you have, right? This is what we humans understand, but the computer doesn't understand it. If you want the computer to understand it, you need to provide the relevant code. For instance, if you want it to understand A, so you need to provide the code for that. This is the code that the computer understands. And this is the combination of zeros and ones. And these zeros and ones are basically, this is a combination of those electrical pulses. This is how your this character is stored inside the computer in this form. This is the form in which it is stored. This is the decimal number system, the decimal number representation of A, 65, and this is the binary representation of A. Now, in the next video, which is lecture 2, we will try to understand the binary number system. So the second lecture is basically going to be a mathematical discussion where we will be trying to understand some mathematics. So we will understand the binary number system in detail in the next lecture. But for now, let's just try to understand this table. So this table basically illustrates that how the characters that we humans understand, all these things that we understand, these symbols, how are they stored inside a computer? How does the computer encode them, right? So this is, and we just saw that it encodes in the binary language. Now this table here is a very old table, ASCII table. As you can see that it only has the English characters here, but you know that there are so many languages that now exist in the world. It's not just the English language that exists. There are several languages, and there are now many things that we have. There's a lot of data that we have. So therefore, this table does not represent all of that. It only represents, this is the older form. Now there are newer versions of this table as well. So one more thing is that there is a concept of the difference between a bit and a byte. We will also discuss that in detail in the next lecture, but bit is just 0 or 1. It's the smallest unit of information, right? A byte is basically, it's equivalent to 8 bits, right? So if you want to like store very simple information, so you would just require, let's suppose the letter A here is stored here with this 1 0000001. This is how this letter is encoded in the computer. For instance, if I want to like send hi, so that hi will be encoded as this 100, 1000, and 100101, right? So what I want to say is that if you want to like send very simple, if you have like a very simple data, so you would just require like few bits to store that. But if you have like a very complex kind of thing that you want to store, then you need more bits to store that thing, right? And this here, this table here just represents the English characters. You have so many characters. You've got Spanish, Chinese, Japanese languages, you've got Urdu, Hindi, and you've got like French, German, and so many languages in the world. So they have their own alphabet, they have their own characters. So therefore you need more bits to like store those. So yeah. Next, let's move on to the next part. I hope you understand till here. In the next part, we just want to understand that why computer scientists use the word information quantitatively. In the last part, we stopped at this point when we said that anything that has got like two states represents the least amount of information. And then we said that this means when we're saying amount of information, we mean that we're using the word information quantitatively. So now let's just try to understand that why computer scientists want to use the word information quantitatively. So the first reason for that is that the way you want to represent your data in computer. So we know that computer deals with binary data, and when you represent this word information quantitatively, that kind of allows you to determine that how many bits are required to represent that piece of information accurately, right? That is that how many bits do you need to store that, to represent that information. So that's one way you want to, so that's how you're using this word quantitatively. Another way is that data storage. Now, computer is an electronic device. It has got a storage system. And of course, that storage system has a certain capacity. So when you're designing storage systems, it's very important to know that how much data can be stored in that given amount of space, because there's a limited space. So you want to know that how much capacity does that storage space have to store the data. And then you have like data compression. That is that you want to like sort of reduce the storage and transmission requirements, right? So you want to use quantitative measures to like assess that. So, and another reason is that when you're like transmitting data, so when you communicate some information, when you want to transmit some information, so that helps. So then when you're using this information quantitatively, that kind of helps you to determine the bandwidth that is required to like transmit that data efficiently. And this can like include calculating the different data transfer rates or maybe error rates and so on. So these are some of the reasons why we want to use the word information quantitatively. I hope you somehow get a sense of it now. So that was it for today's video. I hope you kind of understood what are bits and what is information and how it is stored in computer. In the next lecture, we will be discussing binary number system in detail, where we will also go into the details of what is a bit and what is a byte. The next lecture is basically going to be a mathematical lecture. So there will be a lot of mathematical discussion going on. So yeah, in that lecture, we'll try to understand in detail that what is a binary number system. So yeah, that's it for today. Oops. If you like the video, do hit the like button. If you haven't subscribed the channel yet, please do subscribe. And we'll see you soon. Okay, now I know that consistency is an issue for me. Like there was a lot of delay in this lecture, but now I've like kind of properly made a schedule that is going to help me in like putting the videos on time. So what I've decided is that on Saturdays and on Sundays, I will be uploading the lecture with a gap of maybe a week or two, but not more than 2 weeks. Uh, well, it really depends upon the length of the content. So I'll just stop sharing the screen. Okay, so it really depends upon actually the length of the content and how difficult the concepts are. So if they're like very complex concepts, so that may require some time. So maybe 2 weeks, because when you're like delivering the lectures, there's a lot of research that you need to do before delivering a lecture, because you don't want to give inaccurate information. So yeah, this is what I've thought for now, and I hope it works smoothly. So I'll just end today's video. I hope you understood. I hope I succeeded in explaining what is information, what is data, what are bits, what is the language that computer understands while storing data. I hope that has been made clear. If you still have questions, you can write them down in the comment section below. If you have any feedback, you can also write that down in the comment section below. And I'll now say you goodbye. See you soon. Take care of yourself and goodbye.